All right, well, here's the big lesson on 2.9, and I have another guest here with me today. So this is Mr. Gunn talking about distributive property, and...
Hey, it's T.
All right, and we're going to be teaching you about the distributive property. All right, so let's start out by defining what the distributive property really means. And this is not exactly what it says in the book. This is Mr. Gunn's definition. So the distributive property is really a property that, that helps us deal with multiplication, times an addition or subtraction in parentheses. So let me show you an example. So basically distributive property is sharing multiplication over an addition or a subtraction that is in parentheses. All right? So let's take a quick look at what we mean by that. All right. All right, let's take a look. So here's an example. So suppose I have 3 times the quantity x plus 7. Now this is a great example, and there aren't any actually this fancy in your book, which kind of is a little disappointing because this is the main reason that we need distributive property. So I don't know what x is. Do you know what x is, T? No. So there's no way we can do the parentheses. We can't follow the normal order of operations and do the parentheses first and then multiply by 3 because we don't know what x is. So what the distributive property is going to allow us to do here is it's going to allow us to take this 3 and multiply, see, because really what we do is we'd add x plus 7, and the whole thing would get tripled. So what we're going to do instead is we're going to take this 3 and we're going to multiply times the x, and we're going to multiply times the 7, and we're going to do those separately. So we're essentially going to triple both of these. Now, in terms of remembering the name distributive property, think about what happens in any class when the teacher is handing out a worksheet or a quiz or a test. They walk around the room, and everybody gets one copy. Well, this is kind of like what's going on here. Imagine that x and 7 are T and I, and we're both sitting in a room, and somebody comes in and they want to give each of us $3. So they go over to, well, actually no, that's not a good example. Actually, they want to triple the amount of money that we have in our pockets. So I happen to have X dollars in my pocket. So they walk over to me and they give me 3 times however much money I have. So that would give me 3x. Then they walk over to T, who only has $7 in his pocket, and they say, okay, T, show us how much money you have. And they give him 3 times that much money, so he ends up with 21.
Awesome.
Okay, you see how that worked? So both the x and the 7 got tripled. And that would be the answer, this expression right here. Now, this is a little bit simpler than the top expression because I don't have any parentheses now. Okay, and T knows how much money he has, and I know whatever I had, I have 3 times as much as I had before. Now, if somebody comes along and says x is equal to 5, well, then we could have done it the old-fashioned way. I could have put 5 in here and got 3 times 5 plus 7, and that's 3 times 12. And so total, T and I had $12 between us, and when they triple that, that would give us $36, right? Mm-hmm. All right, let's see if we get the same thing the way we did the distributive property. So again, let's say x is equal to 5, and let's put it into this expression. Well, okay, so I end up with 3 times 5, which is what x is. Okay, so I end up with $15, and T, we already know, ends up with 21.
Oh, yeah.
So I'm going to do this to the left here because I'm out of room here. So I get 15, T gets 21, and again, that's a total of 36. So it works the same way. All right, so we get the same answer if we distribute or if we don't. Okay, and again, to remember this property, remember the 3 is being distributed over the 2 things that are added together in the parentheses. And also, we could have a minus here too. So that could have been x minus 7, in which case we would end up with 3x minus 21. All right, so let's look at some other uses of the distributive property here. All right. One thing that we can do on the distributive property, we just use it on plain old numbers, okay? Now, again, I could add these together first and then multiply. And so T is going to do that. So T, if I do the regular order of operation here, what would happen first? The 3 times or the 5 plus 10 in parentheses?
You would do the 5 plus 10 in parentheses.
Because PEMDAS tells us that this has to get done first, and you would get
15.
Right? Oops, hold on. My stylus isn't working. And then I would do 3.15, which is?
30.
Really? Try again.
45.
That's better, 45. All right. See, we all make mistakes. All right, now what about the other one? If I did order of operations on this one, what do I do first?
You would do 8 minus 3, which is 5.
Right, and then 2
times 2
times 5
is 10.
is 10. All right, now let's try it with the distributive property. All right, so if I do the distributive property, I would multiply the 3 times the 5
15.
and the 3 times the 10. And notice I'm drawing these little arcy things. You actually draw those arcy things. All right, so 3 times 5 is 15. The plus gets carried down, so that stays in the middle, and 3 times 10 is 30. And now, you're not going to make that mistake and say that it's equal to 30, are you?
No.
Because 15 plus 30 is equal to
45.
45. So I didn't even mean to, but this is actually an example where sometimes breaking it up into parts makes it easier. Now this one I think is actually going to be harder if we break it into parts, but let's go ahead and do it. 2 times 8 is?
16.
16 minus 2 times 3?
6.
And sure enough, 16 minus 6 also equals
10.
There we go. So you can see that by doing the distributive property, we get the same thing that we would have gotten when we just do the regular order of operations. Well, all right. So if you're thinking, well, all right, great. I'm so glad the distributive property gives us the same answer, but why the heck would we ever want to use it? What's the use? Here is the use. Take a look at these examples. Suppose you had to do 7 times 98. Quick, T, what's 7 times 98 in your head?
I don't know.
I don't either. Well, what we're going to do is I'm going to show you how to rewrite 98 so that you can do it in your head. All right, you ready? So what if instead of 98, what if we have 7 times, and I'm going to change that to an asterisk because I don't like the other one. It looks like an X. But what if I change 98 into 100 minus 2? Do we agree that that would be 98?
Yes.
All right. T, can you do 7 times 100 in your head?
Yes.
Sure you can. It's 700,
700.
right? Could you also do 7 times 2 in your head?
Yes.
Oh, you're so smart.
14.
14. And 700 minus 14, we got to do a little carrying, but I can do that in my head. I get 800, I get 886. And that was in my head. I could not do this. I mean 686. See, that's why I have extra people helping me. I wish I'd planned that. All right. See, we all make mistakes.
Do I get a +1 for tomorrow?
Yeah, we'll see about that. All right, so we get 686. Thank you, T. That's why I have you along for the ride here, buddy. All right. And again, I could try to do this in my head, and let's actually try it. Let's see. This is not in my head, but let's do a little cherry bomb here. 7 times 8 is 56. You carry the 5. I ran out of room there. 9 times, oh my gosh. 9 times, 7 times 9 is 63. Plus 5 is 68, and we get 6. Oh, look, we got the same thing. All right, I don't know about you, T, but I would much rather do it this way than doing the cherry bomb. And so, especially when the directions say to do it mental math, and I know I just kind of wrote over the directions there, so let me fix that. Especially when the instructions say to do it by mental math. This is much easier than trying to do cherry bomb in my head. And forget trying to do lattice in your head.
Oh my gosh, that would be awful.
It would be. All right, let's try the next one. 103 times 12. Again, I can't really do that in my head. But if I basically the number that is kind of a little bit uglier or bigger, that's the one we probably want to break up. So I'm going to break 100 into 100 plus 3 and multiply that times 12.
Because 12 times 100 is pretty easy.
Yep, 12 times 100 is easy. That's 1200. And 12 times 3 is also pretty easy. What's 12 times 3?
36.
Good, 36. And that one, look at it, put it together, you get 1,236. Couldn't do that in my head, but look how easy it was on paper. All right, we're not even going to do that one with lattice.
Yeah.
So that is an example where even if it's all numbers, distributive property can really help you simplify things and make them a little bit easier. Okay. Now, let's go back to the one that we started with. All right. In this one, we had 3 times the quantity x plus 7. There's no getting around the distributive property here. If there's a variable inside the parentheses, the distributive property is the only game in town. So that's really why this is going to be important down the road. This idea of using it to kind of simplify mental math, it kind of makes it useful for now. And it is. This is a really good trick. I do this all the time in class. You guys don't notice, but a lot of times when I'm doing math at the board, this is actually the trick I use. You just don't see me using it. All right. Now that we've talked about distributive property, I'll talk more about this trick, and you get to actually see me use it. All right. We can also use distributive property for word problems. So here's another one that it's not such an easy problem. I actually took this one out of the book. Suppose videos are $2.80 for each day late. How much would a video that is 5 days late cost? Well, if you know your tricks were multiplied by 5, you can probably figure out that this is $14 pretty easy. You just take half of the 280 and add a 0. So let's say it's not so easy. Let's say instead of being 7 days late, let's say it's 9 days late. What's 9 times $2.80?
I don't know.
I don't either. How about we figure it out? Now this one's kind of interesting. This one we could actually rewrite the 9 as 10 minus 1. Or we could write $2.80. Which do you think is more complicated, the 9 or the $2.80?
Definitely the $2.80.
I totally agree. So let's go ahead and let's rewrite that. So let's leave the 9 alone. And instead of $2.80, let's write that as $3 minus 20 cents. So yeah, we rounded up, but this is actually still $2.80, right?
Yeah.
Okay, all we're doing is rewriting it.
Form.
Now exactly, it's just in a different form. Well put. So now let's multiply the numbers, and I don't even need these extra decimals. 9 times 3 is just 27, and I can add the extra zeros if I want. And 9 times 0.20, well, 9 times 2 is 18. There's 2 decimals though, so it's going to be $1.80. And that's a little tricky, and I have to subtract it. So I'm going to put a minus sign there, and actually, that's going to line up pretty nicely. And I could probably do this in my head, but if not, it's what? 25.
26.
Nope, 25. Don't forget,
25.
you had to borrow here. And 20 cents, right? 25.20. And let's double check this. 25.20 plus $1.80 equal 27. I think it does because the 80 and the 20 cents give us $26 plus one more is 27. So there we go. Wow, that's quite a video rental bill.
Yeah.
You might as well just buy that movie. $25.20. That's probably more than the movie was worth. Let's hope it was a good movie. And so there is a real-life example where using the distributive property really can help us do some arithmetic. So we're going to practice this in class. And sorry that the video ran a little bit late, but let's go ahead and wrap this up. So, oh, I forgot about the screen. A little extra practice. This is how you're going to see it in pre-algebra. So let's just do these real quick, T. What do you think? All right, 2 times 7 is?
14.
14, and we got a minus. Notice the minus just carries over. And 2 times 2x is? 2 times 2 is?
4.
4x's, and that's it. And we're done. And you can't combine 14 and 4x. We'll talk more about that later on.
Do you know what x is?
Well, one's an x and one's a number, so they're not considered like terms. Let's do it again. 3 times 4?
12.
12. And 3 times 3x?
Is 9x.
9x, and the plus carries over, and I'm done. See? You're doing great with the distributive property. And 4 times 2x? 4 times 2 is?
8.
8x's. And 4 times 5 is?
20.
20, and this one was a plus, so we keep the plus. So that is all there is to using the distributive property. Okay? We'll be practicing this in class, but for right now, from T and G, we're signing off.
Goodbye.
Take care, everybody. We'll see you tomorrow.